Okay guys, so today what we're going to learn about is a little bit on cones, generators and how we obtain true lengths based on that kind of concept. So what we're going to do is we're going to start off by just reading the question, a little bit of an explanation here, and then I will take you to a little sketch that I've done that should explain it further. So it says, question 1a, the given line AB is a generator on the surface of a cone. A is the apex. Draw the cone and identify the true length of the line AB. Now, so we have the line AB here in elevation, AB here in plan, and we know that A is the apex. So that's the top of the cone. Now, when we look at a cone in straight on, and if we're standing up looking at a cone shape, what shape do we all see? We always see a triangle. And if we were looking at it from a bird's eye view in plan, we would see it as a circle. And we know that A is the apex, so that's when we look down top of the apex, straight from a bird's eye view, we know that A, even though it's the top of it, is actually also going to give us the centre of it. When we look down at it in plan, the centre of a circle. And we know B is a point where it touches the ground. That means from A to B is actually our radius. So what I could do there is I am going to actually draw the plan version or the plan view of my cone looking down on top of it, because A is the centre and B is the radius. So just looking at this, that is the plan of my cone, and the line AB in plan is a generator of it, and obviously that generator goes the whole way around until it gets back to point B, and that helps to generate the cone. So very, very simple, nice and easy principle there to explain. Now with that, we have to draw the elevation of the cone as well. So bring that up, that's how far it would go out, and bring this up, and that is how far it would go out. And I can join both of them to A, because that is the apex. And there is my cone in elevation, because we see a triangle when we look straight at it, and we see a circle when we look down on top of it. Now, at this point it says, draw the cone and identify the true length of the line AB. Now, why is the line AB here in elevation not a true length? Okay, and that's what I want to get on to explaining. Okay, so what I'm actually going to do is just going to bring you to this little graphic that I've drawn here. Now, on this graphic we can see that we have the vertical plane here, which is essentially our elevation. We've got the horizontal plane here, which is essentially our plan. So you can see when we look down on top of it, the little eyeball here, he's looking down on top of it, he's going to see that cone, but he's going to see it as a circle. And you can kind of see the little circle bit inside here, with the centre, which is directly below the apex. When we are looking at it straight ahead, and it is projected onto the vertical plane, which is the elevation, we are going to see a triangle. Okay? Now, what I want to get at is this little red line here is essentially, and I'm just going to write it in there, is essentially, that is my A, and that is my B. That is my generator of a cone. Now, why is that generator, as I'm looking at it here, not a true length? And the reason it's not a true length is because technically that is actually at an angle to my line of sight at this current moment in time. It's very kind of hard to tell from the graphic, but the only line that I could actually see that would possibly be a true length would be a line that would be out here at the very, very side of the cone, which is the extreme generator. So if I was to put in that extreme generator there, it would look something kind of like, I'll actually put it in a different colour, use blue, and dark blue. Okay, now the blue one is my extreme generator. So all that I have done at this stage is, from A, is that generator that was at B has rotated around until it got to the extreme side of it. That's why it's called the extreme generator. And that extreme generator, at that point, it was to go back like this. That's where it hits the ground. Remember, this is all still B, it is just rotated about it from A, rotated about, gone back, and this is where it hits the ground on the vertical plane, and from there it's going to join up to A. Remember, this is A, this is now our new position of B, and there is how we would see that line in our elevation. And once again, if I just use labels again, this will be my A, this will be my B. But my original B, if I had been to bring it back from here, which is kind of what we have in our sheet, that was my original B. And I'll just use a different one. That was my original line. Now, the reason that the blue one is the true length and not the red one is because in plan, if we're looking down on these two lines in plan, we have this line on our sheet back here, but this line has a different relationship with the vertical plane. It's actually parallel when we look down on top of it, and that's what I'm going to show you on the sheet now in a second. So I'm going to be switching over and back just to explain that. Because when we look down on top of that blue line, what we would actually see is a line from here to here. Because remember, as we look down at it, we don't see A up here, we actually see it kind of down on our sheet down here. And I would see that blue line as a line like that there. And the relationship between that line and this line here, which is my XY line, is that they are parallel. Okay? So, looking at that, I'll take this away. On our sheet, we have the line AB. Okay, that is the generator, which we can see in our elevation up here. Now that generator, and we can see when I did it on the graphic, that just literally rotated about until it came here, roughly there. And if you look at this, so from A, and I'll actually put it in a dark blue. There we go, because that's what I was using. There we go. Now, that line there is the exact same as that line. It's still the same generator, it has just rotated into a different position. It has gone from B here, and it has literally just moved until it got to there. And at this point then obviously it came up, and that means that this line here is actually this line here. So I will now heavy this in my elevation. There we go. And that line there is the true length of my line, true length line A, B. So what we have done there is basically proven that AB there, that's the true length of it out here. But why is it the true length? Once again, and this is relating back to a principle in DCG, any line that is parallel to one of the principal planes in one view means that it is going to be a true length in the other. And in our plan view, we have the line A and our new position of B here. We have rotated the line AB until it is parallel. We have rotated it up to here until it is parallel with the XY line. And that's in plan. That means in my elevation, my new line AB is now, I'll just label it here, a true length. Now that is a very important principle to understand, and sometimes it can be hard to see that on a 2D drawing. So that's why sometimes sketching can actually help you greatly. So we can see here, our original AB, which is what we were given, was a line here, that was the generator of it. All we did was we used the cone principle, so we rotated the B around until it came to this point here. And that line there, coming from the center, because remember A, when we look down it, we will actually see it on our page right here. Even though it's up here, we see it down here on our page, because we see a circle when we look down it in plan. That point right there, to the center, which is our A, that line there is parallel with our XY line. And when we bring that back, that helps to make the extreme generator, and that's why it is a true length. Okay? So, very simple, but really important.